Hello, this video is on statistical processes. Statistical processes refer to the steps we use to analyze data. In statistical process, we have four key processes. The first one is describing data. The second one is organizing and reducing data, followed by representing data, and lastly, analyzing and interpreting data. This goes by the acronym DORA. D for describing data, O for organizing and reducing data, R for representing data, and A for analysis of data. So let's look at these four key statistical processes that we use to analyze data. And remember the acronym DORA that we can use to remember what the four statistical processes are. Okay, describing data refers to reading the data. So based on this article by Curcio, he mentioned that reading the data means extracting information explicitly stated in the display, recognizing the graphical conventions, and making connections between context and data. So describing the data is similar to reading the data that is presented to you, either in the form of raw data, tables, or graphs. Okay, let's look at this example here, where we have a picture graph that tells you that Sam had some friends that come over to visit each day during 1 week in the summer. The number of friends and the days they visited were displayed like this. So the crosses there represent the number of friends who came to visit his house every day of the week in 1 week in summer. So when we ask questions at level 1 of the key processes describing the data, so we call this D1 and D2. D1 refers to description level. Okay, so what does this picture tell you? So that is the kind of question we can phrase at the descriptive level. So we can say that this picture tells us the number of friends that who visit Sam on a particular day for the particular week. And D2, how many friends came to visit each day? So in this question, one may answer that, okay, 2 friends came on Monday, nobody came on Tuesday, 3 friends visited on Wednesday, and so on. So that is the example for describing the data in the context of this picture graph. So based on this graph that you see on the screen right now, which is the prevalence of obesity in the Asian region in 2019 by country, what questions can you phrase? Give me 2 examples. Write it down, D1 and D2, that reflects the D level, which is description of data level, that requires students to analyze in the form of describing the data that they see in this bar graph that you can see here. So prepare your answers so that we can discuss it in the class. So give me 2 examples of describing the data by phrasing your question like how we did in the previous slide. Next, we have organizing and reducing data. So this is the second step in the statistical process, which requires mental action. Organizing and reducing data involves mental actions such as ordering, grouping, and summarizing data. So it's a step above describing the data. As such, it also involves reducing data using notions of center and spread. So usually, for the second step, some operations are involved because you are required to analyze data at a deeper level. Let's look at the same example of Sam and his friends. In this example, you will see 2 questions that requires you to organize and reduce the data. So we call this O1 and O2. O stands for organizing. So O1 states about how many friends came to visit Sam each week. Right, so here in this data that you can see here in the picture graph, you are only given the data for 1 particular week in the summer. So how many friends do you think would visit Sam each week? So this question is an open-ended question where students can refer to the data that is presented to them to give them an idea about how many friends came to visit Sam each week during the summer holidays. O2, what is the average number of friends that came to visit Sam each day? So in this data, you know that the total number of friends who came to visit him is 19 from Monday to Sunday for that particular week. So for O2, you're required to analyze in a sense that how many friends do you think on average came to visit Sam each day? So one may take 19 divided by 7 and come up with a reasonable number to guess how many friends would come every day of the week on average. So those are the two examples of the O level or the organizing level of the statistical processes. So next, based on this example that you can see here, also another picture graph, but this picture graph refers to the number of Smarties in a box. Okay, so this is a picture graph with scale where one full circle represents 2 Smarties, and you're given the frequency on the right column of the table. So this is a picture graph with a table, and it has a scale where one circle represents 2 Smarties. So what you're required to do here is to come up with 2 questions that require students to organize and reduce data. So refer to the example of Sam and his friends earlier and phrase 2 questions that require students to do some kind of mental actions by comparing, maybe calculating averages or make comparisons, and write it down and present it in class later. So the third level of the 4 key processes is representing data. So this includes visual displays of how we represent data in order for us to incorporate visual displays that requires different organizations of data. So this is another step up. So for example, we're required to convert data from a picture graph to a bar graph, from a table to a graph. So this requires different forms of data representation, or switching between one form of representation to another form of representation. Let's take a look at the same example of Sam and his friends. So in this example at the R level, can you draw this graph in another way? So this is a question that requires students to represent the data that they see here in terms of the number of friends who came to visit every day for that particular week, and think of other forms of representation that they feel is suitable to represent this particular data. Okay, so that is the representation level of the 4 key statistical processes. So similarly, for these 2 examples, can you draw this graph in another way? So think of other forms of representation that is suitable for each type of data that you can see here. Remember to write it down so that you can present your answers in class. And the last step of the statistical processes is analyzing and interpreting data. So this includes recognizing pattern and making inferences. As the last step of the statistical process, this step involves recognizing patterns and trends in the data and making inference and predictions from the data. So this extends their thinking in the sense that they are required to use the analysis that they have made in the 3 steps earlier in the process to interpret, in the sense that they can use the information from the data and results from the analysis to extend the inference and predictions from the data that is available. So that requires them to move from the given data to make either a predictions or inference that is not presented or does not have any data to support, but to use the existing data to support their judgment or decision. So in step 4, they are required to read between the data, which involves using mathematical operations to combine and integrate the data to come up with some form of inference, or to read beyond the data, which requires them to use existing information that is not explicitly stated to make an extrapolation or prediction to tell what is going to happen in the future, or to give a sense of probability of the event. Okay, let's take a look at an example here. So we have 5 examples of questions at this level of interpretation. So at the A level, you can see that based on the same example of friends who visited Sam, A1, what can't you tell from this picture? Okay, so this is a unique question because they are required to look at the diagram that's given and tell what kind of information that is not available or not explicitly stated in the data that's given. A2, which day had the highest number of visitors and why? Okay, maybe we can add the question why for A2 so that they can use their experiences to kind of guess why does Sam have so many friends who visit him on that particular Saturday. A3, how many friends came to visit during this week? And A4, how many friends would you expect to come to Sam's place every week during the vacation, and why? So perhaps we add the question why to allow students to justify, okay, based on the cases and the case that's presented to them, why they would think that this number of friends would visit Sam during vacation. And A5, how many friends would you expect to visit Sam during a 4-week period? All right, so these are some questions to allow students to analyze and interpret data based on what it is given and to project their analysis based on what is not given in this data. All right, so here are the list of questions that we've discussed earlier at the description level, which is describing data, D1 and D2. We have the O level, which is the organization level, O1 and O2, and then we have the R level, which is the representation of data that requires them to re-represent the data in other forms, and then we have the A level, which requires them to analyze and interpret the data based on what is given and what is not given in the diagram. So in this slide, we'd like to recap what the 4 statistical processes are. So without referring to the previous slides, can you remember what are the 4 key steps in the statistical process? We have 4 key statistical processes, so if you can remember them, please write them down. Next, we have the term statistical thinking. There are 4 levels of statistical thinking as postulated on the basis of the Solow model. Remember, you don't have to memorize any of these 4 levels of statistical thinking. In this video, I'm just going to explain to you what levels of statistical thinking students get involved in so that you are aware that there are different levels of maturity when it comes to statistical thinking. So we have the idiosyncratic level, the transitional level, the quantitative level, and the analytical level. So let's look at some examples of the idiosyncratic level. So level 1 thinkers, or at the idiosyncratic level, students are constantly limited to idiosyncratic reasoning that are often related to the given data and frequently focus on their personal data banks. So sometimes at the idiosyncratic level, some of the answers that students give are not relevant to the data or does not directly answer the question. For example, at D1, the question was, what does this picture tell you? So they might come up with answers like there are 19 crosses in the picture. Well, technically that is true, but it doesn't give us the correct representation or the correct information about what the whole data is about. O2, what is the average number of friends that came to visit Sam each day? So they might say 2 friends came to my house last week. So at the idiosyncratic level, they might give an answer that is relevant to themselves. And at the A4 level, how many friends would you expect to come to visit Sam every week during the vacation? Then they might guess, say 6, otherwise they'd trash the house. You can see that some of these responses here are not directly related to the data that is given. So that is level 1, idiosyncratic. Level 2, transitional. Level 2 thinkers are more matured in the sense that they are beginning to recognize the importance of quantitative thinking, and they can even use numbers to invent measures for center and spread, but this may not always be valid or accurate. Nevertheless, their perspective on data was generally single-minded, and they seldom connect representations or analysis of the data to its context. Let's look at some examples. So for example, what does this picture tell you? So level 2 thinkers might say, it tells you how many friends came over and it tells you the day. So this information is half correct, but it is not exactly accurate because they do not elaborate on how many friends are there in total or what other data or what information is available in the graph that they see. At the O2 level, for the question, what is the average number of friends that came to visit Sam each day? So between 7 and 0 is somewhere there, but I don't know. So they might not be able to justify or validate their answers, and this is purely based on guesses. And A4, how many friends would you expect to come to visit Sam every week during the vacation? So they may guess like maybe 19, but I'm not sure. So again, transitional level is a step up from level 1 thinkers, but their analysis may not be very accurate, and sometimes they may rely on guesses rather than the data that is presented to them. Now let's look at the quantitative level. So this is level 3, where students exhibit some form of thinking that consistently use quantitative reasoning as the basis for statistical judgment. So here they may form statistical analysis based on the kind of representation that they are given, which involves some kind of mental computation. So let's look at some examples here of level 3 quantitative thinkers. So what does this picture tell you? The same question. So they may say that it tells you 2 visited on Monday, 0 visited on Tuesday, and so on. You can see that these answers here are more accurate and elaborate as compared to level 2 or level 1 thinkers. The second question, what is the average number of friends that came to visit Sam each week? So they may say 2 because 2 came on 2 of the days, it is the most, so they may come up with certain justification on how they get the average value. And lastly, how many friends would you expect to come visit Sam every week during the vacation? They may guess a number, and they may give you a valid reason as to why they think it is between 10 and 15, because maybe they think 19 would have been too many during the particular week during vacation, because some might have gone to visit somewhere else. Okay, so this is level 3 quantitative thinking, and you can compare the responses for each level based on the levels that you've seen earlier, the idiosyncratic level and the transition level. And lastly, we have level 4 analytical level. So analytical level is the highest level where they are able to explore the data while showing evidence of being able to make connections among different aspects of the data. So this is the highest level, and let's look at their responses here, and you can compare that to the 3 other previous levels that we have discussed earlier. So what does this picture tell you? It tells you about friends visiting Sam. So here the student is describing in general the overview of the data that they see, and then they can go into specific where they describe 2 visited on Monday, 0 visited on Tuesday, and so on. Second question, what is the average number of friends that came to visit Sam each day? So they can justify with almost good accuracy with valid reasoning. Like for example, they may say about 3. So you can share them, as in share the crosses. So take away 3 from here, which is the 7 who visited on a particular day, and then give it today with 0 and so on. Then they'll all have about 3. So if you refer to the graph that you see earlier, so if you redistribute the crosses in the diagram, you will see that the average is right about 3. And this is how they justify the answer. And lastly, how many friends would you expect to come visit Sam every week during the vacation? So well, since there are 19 this week, there's a good estimate. So maybe they'll say there's about like 20 because there's so many on Saturday. Okay, so for more information about statistical thinking, you can go to Assessing and Fostering Children's Statistical Thinking or refer to the PDF copy in the link here. So thank you very much for watching. If you have any questions, do remember to write it down so that we can discuss in class. Thank you.